The American Geophysical Union is a robust global network of science disciplines in earth and space science. And the fall meeting is the most influential event in the world dedicated to the advancement of earth and space sciences. Hello and welcome. I'm Laura Krantz and we are thrilled to be in Chicago for the first time as the 2022 AGU Fall Meeting gets underway. For the next 4 days, we will be bringing you sit-down interviews with those having the biggest impact in the earth and space science community. We'll take you on a tour across the globe of the universities, institutes, and research centers at the forefront of the exploration of earth and space sciences. There will be something for everyone, and we want to make sure you don't miss a minute. You'll be able to find all the latest episodes and content of AGU TV on the in-house channels of our partner hotels, on our dedicated page on the AGU website, and of course, always on our Twitter and YouTube channels. Plenty of ways to watch. Our focus today is on the future of our planet, and we start with our conversation with Carmen George, whose COPE program is making sure food isn't a luxury item. So let's start by talking a little bit about where you're from, what the environment is like, and why you're doing the kind of work you're doing there.
Yeah, so where Navajo Nation sits is between what we call our four sacred mountains, and so that's where we live and reside within those mountains, and we have some rivers there, underground water. It is pretty sparse as far as grocery stores. There's probably about 13. I think they built at least another one, so there's probably 14.
But 14 in something the size of West Virginia is not very many grocery stores.
So, but we have over 100 convenience stores, and so our organization, we try to work with not only the big grocery stores, but also the smaller convenience stores in the communities to help them to offer fresh fruits and vegetables to the community.
Okay, and tell me a little bit more about your organization. What's the name of it? What are the goals?
Yeah, so I work for an organization called Community Outreach and Patient Empowerment. It's a sister organization to Partners in Health out of Boston. And so within that, I work on the research and evaluation team, which sits under Brigham and Women's Hospital. So all of those are connected through our Partners in Health network. And so that's, we're a nonprofit, Native-led, and we work on different public health initiatives. We have like the fruit and vegetable prescription program, we have the water promotion program, we have training and outreach. We work closely with the community health representatives on Navajo Nation. So that's just kind of a small part of what we do. There's more that we do in the public health field.
Yeah, and there's a lot of focus on water. You know, obviously being in a desert area, water is very important, and also water has a lot of meaning for people on the Navajo Nation.
Yeah, so we do try to promote water. So when I first joined COPE, we were promoting fresh fruits and vegetables. And then a few years later, we realized it's also important to promote healthy beverages, because people might be eating healthy, but maybe they're eating a salad with a soda. So just trying to promote healthy eating and drinking on Navajo Nation, I feel like that's important. And there's a statistic that says that 1 in 4 children on Navajo will develop diabetes type 2. And so because of that, we're just trying to prolong that diagnosis. So it's not if, but it's when they will get diabetes. And so I think that was really stunning to me. And so just trying to develop those healthy habits at an early age where children are choosing fruits and vegetables, water, unsweetened drinks. I feel like that's really important because in the long run, that'll help to push back that diagnosis of diabetes, and they won't have to live with that, early on in their life. And I think now they're starting to diagnose them earlier. So even kids like 12 years old are developing adult onset diabetes, and that's really
tragic.
Yes.
Yeah, it is. And then there's an element of sacredness too to water in the Navajo Nation.
Yeah, so I feel like it's really important when we talk about water, and especially with the youth, to talk about the cultural and traditional aspects of water, because water, like my clans, we have all of Navajo people, we have 4 clans, and so a lot of our clans stem from water. So there's a lot of the names of our towns are in water. There's a lot of sacredness in water because water is considered a living being. And so that's really important when we talk about water, because we want to be reverent to it and be positive. And so I think that's one approach that we try to do with our project, is to always be positive and to speak kindly about water, because it is very sacred and it's really important to keep that in mind.
Yeah, that seems like a lesson that everybody could take from you in terms of, as we move forward and with climate change and with the potential for drought and water becoming a scarcity and a much more valuable resource than it already is, thinking about it from a sacred perspective and something that we should be protecting. So that does seem like something that scientists and people all over the world could stand to learn from your community.
Yeah, I think that's really important, and something that I hope that this project that the youth come out with, like I hope when they finish our project that they have that respect and that they do that they have that reverence for water.
Yeah. Well, thank you for joining us today, Carmen George. It's been a pleasure talking with you.
All right, thank you.
Turning to the Smart Farm program at the University of Illinois, where their objective is to bridge the data gap in the biofuel supply chain by funding technologies that can quantify feedstock-related emissions. Let's see how they do it.
We had an anniversary on the 15th of November where the world's population passed 8 billion people. And the challenge we face is how to feed 8 billion people and a growing number of people on the planet sustainably in a way that is healthy for the environment and healthy for human beings.
The Agro Ecosystem Sustainability Center is a new University of Illinois initiative targeted at developing the most advanced sensing, modeling, and quantification tools to better understand holistic agriculture outcomes, including productivity as well as the sustainability metrics. Not only we are generating the most advanced science and technology to address this problem, but we also hope to deliver these science and solutions to the hand of stakeholders, including farmers, policymakers, and industry people, such that we can collectively build solutions together.
When it comes to the causes and mechanisms of variations in the oceans and atmosphere, and how such information can help anticipate future impacts under global change, our next guest, here in studio, Kai Thirumalai, is a leader in the field. We're joined now by Kai Thirumalai. Kai, thank you so much for joining us here today.
Thanks for having me.
Yeah, so my question is about the research that you've been doing in the Gulf of Mexico and the poster that you're going to be you're a co-author on, and I guess you're co-presenting. Can you tell me a little bit about what you're looking for and what that research involves?
Yeah, thank you so much. I'm happy to share. I'll just preface by saying that this is actually a poster that's being presented by a student at the University of Louisiana at Lafayette. And her name is Gracie Babineau, and she's done the majority of the work on this poster. But basically, this work is focusing on trying to understand the ancient history of methane seeping out from marine sediments, basically. So at the bottom of the seafloor, we're trying to track how much methane actually was sort of expelled from these sediments and how much methane actually was released going back thousands and 10,000s of years ago, basically.
Okay, and the goal with this is to, what are you trying to understand by tracking this methane?
So methane is an extremely potent greenhouse gas, and we're really concerned about rising levels of methane in the atmosphere. And there are points in Earth's history where we think that methane may have actually played an important role in global warming events. So what we're really trying to do is trying to understand the history of methane release from seafloor methane hydrates and methane vents, basically.
Okay, and how does what you're finding in these core, the sediment layers, these cores, how does that apply to what's happening with the climate now?
So one potential kind of concern, although there are many ideas that say that this is not something that's an imminent worry, but we know from Earth's geological past that during global warming events, the ocean heats up so much that some of the bottom layers can actually warm up and destabilize these methane hydrates. Okay, so the concern is that, can this even be a possibility with anthropogenic global warming? Is it possible that we can warm up the Earth so much that the oceans heat up so much that these methane hydrates ultimately get destabilized and you release more methane into the atmosphere? So we're trying to investigate whether these things can actually happen and how these things actually change going back in time throughout Earth's history, basically.
Okay, so a lot of this methane then is trapped at the moment because it is so cold, because so the cold mud then, or the sediments trap that stuff. As it gets warmer, it can seep out, rises up through the ocean, gets burped out into the
That's perfect.
into the air,
yeah.
and then that just accelerates the global warming process.
That's exactly right. You described it really well. Yeah.
How do you know at what point, like, how will you figure out if this is actually happening?
So the first aspect, and that's really what we're delving into in this poster essentially, is can we actually track these things? We're trying to ground truth whether we can actually characterize the history of methane release from these locations where today we know there is methane seeping out today from these locations, okay? And so we're really trying to track their history of these vents that are today releasing some amount of methane, but could they have released at different rates back in time? And the way that we're trying to do this is by using these tiny little ocean bugs known as foraminifera. And in particular, we're focusing on benthic foraminifera. Benthic just means that they live at the bottom of the seafloor. And these foraminifera are basically living on top or within the mud that houses these stable methane hydrates and is the site of sort of methane seepage today. So we're trying to track whether the foraminiferal shells that they build, whether they can actually hold some types of signatures of methane release. And then we can go back in time because we find these shells in the sediment layers that allow us to go back in time.
And then that also sort of allows us to potentially predict the future a little bit here.
It definitely allows us to understand the system better, and that makes the system more predictable for the future. We're actually analyzing individual shells of these foraminifera. These are really, really tiny shells. And we're analyzing multiple individual shells from the same sedimentary layers. And so the real cool thing is that the lifespan of one of these individuals, of these benthic foraminifera, is probably, we think maybe a month, maybe a couple months, maybe a year. Some people have said they can live as long as a year. So what we're analyzing is individual months or years by characterizing the isotopic signatures in these foraminifera. So we're getting a kind of a monthly view into thousands and tens of thousands of years ago.
Kai Thirumalai, thank you so much for joining us here today.
Thank you very much.
Continuing with our focus on oceans and atmosphere, we head to the Environmental Fluid Mechanics Lab at the University of Notre Dame, where they are studying everything from monsoons to microclimates.
We study the dynamics of natural fluid motions. That includes the atmospheric, oceanic, inland waters, as well as engineered flows, which are, for example, urban flows as well as engineering industrial flows.
Well, we don't like to reinvent the wheel. We will try to get as close as we can with a commercial piece of equipment, and then we will build on it to get the data that we need.
We really identify what are the current interests of the society. Then we select few of them which we can handle, and then we design programs.
Over the last 7 years, there's not a lot of places the equipment that we build and develop and maintain down here hasn't been. It's been in 3 different oceans, tops of mountains in Europe and America, and on both different coasts.
One of the key components to the fall meeting is the ability to network with fellow scientists and peers in the research community. And this year, there is a new place to do just that, in the Brain Date Lounge. Let's go. Graziella Caparelli is finishing out her first successful year as the editor-in-chief of Earth and Space magazine. She joins us now in studio. We're joined now by Graziella Caparelli. Graziella, thank you so much for joining us here at AGU.
Thank you for inviting me.
Yeah, well, it seems like you have the perfect job given your background at Earth and Space magazine. You've done work on Earth, and now you've done work in space with Mars. Can you talk a little bit about your research and what you've been doing?
Yes, I am a member of the scientific team for the MARSIS, which is the ground penetrating radar on board Mars Express. It has been observing Mars since 2005. In fact, that's when the radar was activated. And I am part of the team that found liquid water at the base of the South Polar Cap on Mars. So we've been working on that for several years now, and I am quite honored that I was invited to be part of that team. And I will be presenting about that work at this conference.
That's really exciting.
Yes, it is.
Yeah, I'm sure finding liquid water on Mars is sort of the first step to maybe finding some life up there, or at least...
Yeah, it is actually extremely cold, naturally, as you can imagine. And at the base of the South Polar Cap, we are talking about 1.5 kilometers underneath the surface, so it would be very difficult to reach. But because we think that the liquid water must be extremely salty, so there's a possibility that in those environments there may be some microbiota that can survive or that can metabolize particular chemical elements.
So your focus has been planetary formation and evolution. You started obviously doing that here on Earth. Is that the kind of information you've been looking for on Mars as well, aside from the work with water?
Yes, that's correct. I mean, essentially, of course, I am a geologist, which means I studied planet Earth. And what we do is then translate the knowledge that we acquire by studying planet Earth to other planets that are similar to Earth. So Mars is one of the terrestrial planets, which means it's made of the same building blocks as Earth. And even though naturally, because of its size, because of its position relative to the Sun, which is different than Earth, it had a different kind of evolution, but the principles are the same.
What do you think we'll learn from Mars that might help inform what we know or what we come to learn about Earth?
Well, there's always the aspect of the more you learn about other planets in the solar system, the more you understand also planet Earth. Just to look at something which is very simple and very obvious. Earth has plate tectonics, so a lot of the most ancient crust of Earth has been recycled, whereas on Mars we still find crust that is 4 billion years old. So we can draw some parallels between what may have happened on Mars at the time, because we don't find that evidence on Earth anymore. But of course there are many more questions that we can address by comparing different planets, and that's quite exciting because you can find lots of information and then figure out, like a detective, oh, I think I found that clue on that other planet. What may it mean for Earth? So everything is connected. The solar system is like a giant system, and we are just piecing together pieces of the clue.
Yeah. Does the work you've done on Mars, especially with water, sort of make you think of the fragility at all of Earth?
Absolutely. I mean, certainly not only Mars, but also Venus. Venus has this huge greenhouse effect. Naturally, when we start thinking of these kinds of processes, we worry about what might happen to Earth if we let it go too far. So naturally, if you look at other planets and consider the evolution that they have had, it takes just a tiny little difference to then make a planet uninhabitable. And so we really have to be very careful for Earth as well.
Going back to your work at Earth and Space magazine, you've said that you want to increase diversity at the magazine. Do you feel like you're accomplishing those goals, and what would you like to see going forward?
There's always more work to do. So I am very proud actually, because in terms of gender representations, we are, some of the best journals in the universe, I believe. But I need to achieve more geographic representation. So most of our editors are from the US or from Europe, and that's fantastic, but we receive a large amount of submissions from countries outside of the US and Europe. And we need to have adequate representation on the editorial board for that as well. So I'm looking to recruit associate editors. In fact, if this goes on, I am looking for associate editors, and we will train them well and we will treat them well. Our scope is basically all of the disciplines of the AGU. So any field that of research, any young early career researcher, mid-career researcher who might be interested, we would certainly consider their CV, because we are looking.
Graziella Caparelli, thank you so much for coming and joining us today.
Thank you for having me.
It's been an incredible year for AGU CEO Randy Pfizer, overseeing the AGU community of 60,000 members and pushing the limits in Earth and space science research and discovery. Atria Godfrey sat down with Randy at the AGU headquarters to discuss what we can look forward to this year.
Now to welcome you to the AGU Fall Meeting, we are joined this morning by Randy Pfizer, CEO of AGU. Thank you for your time today.
Oh, thank you for having me. This
Absolutely.
is great.
All right, let's dive right in. So
Sure.
This year's theme is Science Leads the Future. What does that mean to you?
So to me, Science Leads the Future is really about how the information that our scientists gather and study is really important to how we make decisions about where we go in the future. I mean, look at the issues that we're dealing with in society, climate change. We have other types of societal challenges that we're dealing with, environmental justice issues, sea level rise. All of those things are just, things that we are facing in the future, and lots of decisions need to be made around that.
So how do we make sure that science stays at the forefront when it comes to tackling some of those problems?
I think that's a great question, because it's really important that scientists learn to communicate their science to the general population. We need to do it not as scare tactics and get people freaked out that, oh my God, the world is ending, but do it in a way that really shows that one, we can convey the information that makes it understandable, makes it actionable, and really touches in people's values and how they believe the world is structured and what they care about.
You touched on this just a moment ago, but the word future, we would like to think expresses hope and optimism, but I don't have to tell you that certainly in this atmosphere these days, sometimes it can also elicit feelings of fear and uncertainty. How can science keep it positive?
Yeah, it's a great question as well. The thinking about a sustainable future and really painting the picture that if we do the right things as a planet and we do the right things as people on this planet, that we really can actually create a future that everybody is going to be excited about, that we are going to be happy that our grandchildren can live in, and that we can really do the right thing as a planet and create this environment that we know we are capable of doing. So I think always, putting out the challenges, because we got to let people know what we're facing, but doing it in a way that says, but if we do that, this is what the future could look like for us.
Well, the fall meeting this week is a great opportunity for researchers and scientists to exchange those messages. What are you looking forward to in the week ahead?
Well, one is just seeing everybody. I think it's always great to bring this community together. And with we're looking at about 23,000 people being here. And we think 80% of them are going to be in person. We are going to be looking at areas of diversity, equity, and inclusion as a community environmental justice. We're also looking at climate interventions that are taking place, and really how can we address some of the challenges that are going to be faced with that. So it's just really incredible when this group gets together and how much knowledge and information is shared in one place.
You mentioned some of the new initiatives that AGU will be embarking on for this year's meeting. Any one in particular that you are most looking forward to or that you think might be the most impactful?
I think there's a really important effort that AGU started on this last year, and that is exploring an ethical framework for climate intervention. So we absolutely think it's critical as a community of Earth and space scientists that carbon dioxide emissions reduction takes place, point blank. We need that to happen. However, there's been a lot more evidence that the goals that we've set for ourselves as a planet to maintain what we need to do in order to achieve or to stay under 1.5 degrees Celsius we're not on that path, and we're not on a good path. So there's been a lot of exploration going on in the scientific world around how do we possibly intervene in climate change with different tools and mechanisms that are not just about emissions reduction. So AGU is developing an ethical framework which is going to put a construct around those research initiatives to have conversations to say, is this the right thing to be even doing and thinking about? And it's really, I think, an important part that the scientific community, along with partners, can play in the future of this planet.
Very. Going back to the theme, science leads the future. What are the ingredients for success when it comes to science staying at the forefront of our future?
Yeah. I think it's having open science so that the science is accessible to all. And then having that translation and ability to communicate it in a way that it makes it understandable to everybody. And I think those things are the key ingredients, and AGU is working on both of those.
All right, well, best of luck this week.
Thank you
for your time
Thanks
this
for
morning.
Being here.
AGU CEO Randy Pfizer.
We hit the conference floor to hear from you. Today we are talking with attendees about what they're looking forward to at AGU this year.
I'm really excited to be at AGU to meet other climate activists, other scientists who are activists, so that I can network and kind of build a bigger movement around climate justice. I've seen a lot of different sessions on the energy transition, and my work is on electrification and the ways in which it's impacting indigenous communities negatively, so I'm really excited to see what people are talking about.
I'm very excited for all the networking opportunities and the opportunities to learn about everyone's research. Ben Gutenberg lecture. It's like the biggest lecture in seismology. I'm a seismologist. So yeah, I'm very excited about that.
I'm really excited to talk about all the research that I've done for my dissertation, and also to talk about the academic worker strike that we have are on the 5th week of at University of California. And just talk to other grad students and postdocs and people who need a better, living wage and fair contract in academia, so we can make academia more inclusive to all.
I'm attending AGU as an early career scientist, starting at Pacific Northwest National Laboratory. There's a lot of discussion on how aerosol can help nucleate ice, and so that's a really big part of our field, and there's a lot of great scientists working on that topic.
This is my first time chairing a session, so I'm really excited. This is my first time to introduce speakers and talk about the science that I'm excited about. I'm also excited because I want to meet a lot of other people. This is the opportunity to network, find collaborators, talk about science, get ideas, all of these things. And really just to see friends and hang out with them, I think that's a great opportunity.
The complex processes impacting the lives of everyone on our planet are impossible to understand from the perspective of isolated fields. Check out how the University of North Carolina is using connected systems to understand past and future for Earth and ocean.
We study everything from the deepest oceans to the oldest rocks. What we're really interested in is how those different things are all connected to each other. Before we had our combined department here at UNC, we had separate departments, and we didn't always interact as much as we could have. And we were really missing opportunities to study things between the continents and the ocean.
I study natural disasters and the way that they impact communities, and the ways in which the environment and human decisions are changing over time to exacerbate disaster impacts.
My lab is specifically investigating how bacteria use unique molecular weapons to kill each other as they compete for a limited space and resources.
We want to be the place in North Carolina and really beyond that you come if you want to understand these interdisciplinary connections between continental processes and oceanic processes.
And that brings us to the end of day one of AGU TV and our first episode, The Future of Our Planet. We hope you've enjoyed learning about the different institutions at the forefront of Earth and space science research, and hearing from those working hard to preserve our beautiful planet. Remember, if you missed any part of today's show, there are plenty of ways to catch up. There will be something for everyone, and we want to make sure you don't miss a minute. You'll be able to find all the latest episodes and content of AGU TV on the in-house channels of our partner hotels, on our dedicated page on the AGU website, and of course, always on our Twitter and YouTube channels. Plenty of ways to watch. Thanks for joining us today. We will see you right back here tomorrow for more exciting news and highlights from the AGU 2022 Fall Meeting. Have a great one.